Okay, we're trying another distance problem here. Let's read it together. We have David leaves Sturbridge at noon at 40 miles per hour. 2 hours later, Robert leaves Sturbridge in the same direction heading at 60 miles per hour. At what time will Robert catch up to David? Okay, this is the same scenario with your mom catching up to the bus. Imagine what's going on. You have two people there in Sturbridge. David's going to leave Sturbridge at noon. He's traveling 40 miles an hour. What's Robert doing? Nothing yet, right? It says 2 hours later, now Robert's like, oh, I need to go catch up with David. So he's going to leave Sturbridge also, heading in the same direction, but he's traveling faster so he can catch up to him. Can you visualize this? Two people leave Sturbridge. He left. He's just going slow. 2 hours later, this guy kicks into gear and he's like, oh, shoot, I better leave. He gets in his car and he's going just faster, so eventually they're going to catch up. Does that make sense? You see that? Okay. The way I set up the chart is the exact same way. T is still going to represent the time. If you want to say number of hours to be more specific, that would be good too. Because this is not time of day. I know they said noon. I actually don't really care about that until the end. So this is hours, time in hours. It does not mean I'm going to put a 12 in for noon. Watch how this works. David, do you know his rate? 40. David leaves Sturbridge at noon at 40 miles per hour. So we put in a 40 for David. Robert, do you know his rate? 60. Okay, those are the easy parts. Now let's talk time. All right. Do you know, let me ask you this. Have the two guys been traveling for the same amount of time? No. No, this is different. Remember, David left. Robert's just hanging out, drinking a soda or something. He's not traveling. He leaves. This guy's been traveling how long? Well, 2 hours when this guy leaves. But in all, when they finally catch up, do you know how long David's been traveling for? I don't know yet. I'm going to call it T. Now, how do you show Robert?
T plus 2.
T plus 2 is a very common mistake. Let me tell you why it's a mistake. That would be saying that this guy that's hanging out drinking the soda, has he been traveling for 2 hours more than this guy? No. He has actually been traveling for 2 hours less than this guy. Does that make sense? He's going to leave. He travels for T hours. I don't know how long he's going for. This guy's hanging out having a soda, and then 2 hours later, now he kicks into gear and starts going. So whenever they meet up, I still don't know when that's going to be. But I know that this guy has been traveling for 2 hours less than this guy has. So I got to do T minus 2. You follow me? That's one of the biggest mistakes, is that kids put a plus 2 there. So every time you do that, I need you to stop and think, who's been traveling longer? David has in this case. So make sure that this number is smaller than that one. Doesn't T minus 2 have to be smaller than T? Yeah, take a number and subtract 2 from it. Of course that's going to be the smaller number. What do you do now that you have rate and time filled in? Good answer. Yes, you multiply straight across because distance is equal to this times this. So once you have these two columns, you multiply straight across. What's 40 times T? 40T. Be careful down here. What's 60 times T minus 2? $60T minus 120, right? You have to distribute. You're doing 60 times T and 60 times negative 2. 60T minus 120. You follow me? See, the chart's not so bad. Once you have the chart filled out, then you just have to go back up to the top and ask myself, okay, well, what kind of question is this? Are the two people traveling in opposite directions? No, so that's not the scenario I have. Are they traveling in the same direction? Yeah. David went, and then Robert's like, oh, I got to catch up. They're traveling in the same direction. So what does it say? Set the distances equal to each other. Why would you do that? Think on it. Two guys leave Sturbridge. He leaves. 2 hours later, he leaves. When they catch up to each other, didn't they go the same distance? Yeah. Let's say that they met up in Worcester. They traveled from Sturbridge, and when they finally caught up to each other, they were in Worcester. The distance from Sturbridge to Worcester is the same, no matter how long it takes you to get there. Right? If you rode your bike or you drove a car from Sturbridge to Worcester, you went the same distance. You just did it in very different times. Get what I'm saying? The distance that you went is the same. The distance these two guys went is the same. So all I need to do is set their two distances equal to each other. Just like it says right at the top. Oh, for people that are watching this video, they don't know what's at the top because they don't know that this is video 2. Same direction. Set distances equal to each other. So, what's my equation going to look like? If I set the distances equal to each other, who can tell me? Paige, you tell me. If the distance David went is equal to the distance Robert went, how far did David go? What's his distance? You know it. It's in the box. David, how far did he go? What's David's distance? Huh? 40t. Yes. 40t. You set that equal to Robert's distance. What's Robert's distance, Paige? The whole thing. 60t minus 120.
Wait, why would it be minus 120?
That's
Oh, right.
okay. So when you have two people traveling in the same direction, you just set their distances equal to each other. So once you have the chart filled out, you just look up at the top and you figure out, okay, what am I doing with these? Do I add it together, set it equal to something? No, in this case, you set them equal to each other. Now, guys, all you have to do is solve it. Now it's an equation. You can forget for a moment that it's a word problem. Let's solve it. Minus 60t from both sides. That's a negative 20t equals negative 120. Divide both sides by negative 20. Watch your negatives. What does this turn out to be? Not 60, it's 6. Which makes sense. I can't have negative time. So since I'm solving for time, if you had gotten a negative number, that would have told you, hey, you just messed up the negatives. By the way, I love this. Kids sometimes, like, they'll get an answer -6, and they're like, oh, it's not supposed to be negative. I'll just erase it and hope that it's right. How about you go back and try and figure out where your error is? Yep.
That worked for me once.
You got lucky that one time. It's not going to work for you every time. Be careful. All right. Now, I still have to answer the question because I haven't yet. At what time will Robert catch up to David?
Oh.
This is now asking you for time of day. So here's what we know. T is 6. How long has David been traveling for? How long? How many hours? How many hours has David been traveling for? 6. What time of day did David leave? He left at noon. So in this case, it just so happens, I kind of wish that we had set it up differently. He's been traveling for 6 hours and he left at noon. So what time of day is it now? 6 p.m. It is 6 p.m. when they meet up with each other. But you might be saying, well, hold on. How did you know to deal with David? Why didn't you deal with Robert? You could have dealt with Robert. When they meet up, isn't it the same time of day, whether I'm talking about David or Robert? Right? It doesn't matter which one you focus on. Let's say you were to focus on Robert. How long has Robert been driving for? How many hours? 4, right? Because it's T is 6. 6 minus 2 is 4. So why isn't the answer 4 o'clock? He left 2 hours later. Remember, Robert's sitting there drinking the soda until 2 o'clock. Then he gets in his car and travels for 4 hours. So 6 o'clock is when they meet up. Whether you're talking about David or Robert, it doesn't matter. Here's what I don't want you to fall. Someone's going to fall into this trap, and I don't want you to. You're going to think, oh, T is 6 hours, so that must mean that they met at 6 o'clock every time. What if David had left at 1 o'clock? The whole thing shifts then. You have to think what's 6 hours after 1 o'clock. Then the answer would have been 7 p.m., right? Also, a.m. and p.m. matter. So is it 6 a.m. or 6 p.m.? p.m., because we're talking about 6 hours after noon. Noon is 12 p.m., so 6 hours later would be 6 p.m. So give me a sentence that says, they will meet at 6 p.m. Really? We have to say a.m. or p.m.? Yes, because sometimes it matters. Well, it always matters. All right.